So we have 2 minutes taken now. And Hawkins and Scott.
Minus 1 minute till the
Oh, we are supposed to be sucking already. All right, is this one? Which way is it? Oh, it's on. All right. Okay. So, okay, so I'm Turkin and this is IPSECME. I think it's 1 minute past, so we can start. All right, so let's see. So,
our AD has skipped out on us, so Paul will tell him whatever bad thing we do here.
yeah, so okay, so this is the note well. You have probably seen this before, so note it well. And we have already taken 2 minute take. It's much easier when you offer gifts or small presents. I got a new 3D printer, so I have that. Here is the notes. If you can actually, you can. I think the note links is correct, but if it isn't, you can actually find it in the agenda also. But other people can also go there and fix up, and especially if you ask some question, you can go and see if your question was correctly, typed in or answered or something like that. All right, so we have a very tight schedule because we have a full agenda, but I don't know actually how long those presentations are going to be. But so does anybody have any, comments on the agenda or anything? If not, we go forward. So the working group status report. So we have published 4 new RFCs since last time. So the IPTFs and the young and mid models went out, and then we have this TCP encapsulation BIS document. So we have finished some work out. That's fine. We have 2 documents in the RFC editor queue. One is the IC version 1 algorithms to historic, and then there's multiple key exchanges. I think both of them are actually the multiple key exchanges is very late in the. I think it's an out to 48 or something like that, and if I remember correctly. And then we have one that is in labeled up IPSec is in IETF last call, I think. And then we have still this ADD. IC was actually waiting for the AD to actually look at it, and he said that he actually going to do that like in week or 2 or something like that. But and then we have a working group last call for 2 documents, which is actually I just remove or drop the GIC version 2 out from the working group last call, and I'm actually going to be making a ask for directory reviews for that, early reviews for that, so we can, because we haven't been able to get that many reviews. There was actually Daniel's review, which was good, and I think Paulo has promised to do some review, and I have promised to do review, so we hopefully can get those done in quite soon, and then we can actually kick it out. And then we have the out announce, which is Paul had some comments, and I think we are going to be doing some changes and then probably make a second working group last call for that. And then we have a couple of documents that are still in the process of being worked on. All right, so the next is Oh, so yeah. The next is then we start go to the does anybody have any questions about the working group documents or anything like any other that are not covered by the presentations already? All right, so let's go to the first presentation then. That's Paul with dark theme slides, which shouldn't be done anymore because the working group chairs list said that we shouldn't be doing that.
Pretty light. Oh, it's a little darker. Okay. So this is mostly stemming from Tobias and me actually working on the implementation, and I have to say that Tobias got much further than I did. So most of the comments are actually inspired by things he found while implementing this. So the first item is that the handling of the SPI between the IKE rekey and the optimized rekey is a little different. Normally, when you send a create child essay for the rekey, you don't send the SPI and then you know it's an IKE rekey, or you send the SPI and then you know it's a child rekey. And now it's a little bit changed because you still send the SPI for either, but only based on the SPI size can you detect whether it's a parent, whether it's an IKE, or whether it's a child essay. So the question was, since obviously I at least ran into this a number of times, I had to reread it and figure out how to do this. I think the text needs to be improved at least. And the other question is like, do we want to use a separate notify for the IKE SPI to make this more clear or not? I'm not sure if you want to do questions per slide because basically each slide has a question, or whether should I just do all the slides?
I think it will be. It's actually up to you, but I think it might be useful to have a comment directly here because.
Okay, sure. So, does anyone else has comments on this? My preference probably is just to leave the text as is. Sorry, to improve the text, but leave the wire format as is. Okay, so next slide. The next one is about when to send the optimized rekey supported payload. It was supposed to be sent in an IKE auth, but there can be multiple IKE auth exchanges. So in which one do you send it? So the proposal here is that the initiator keeps sending it in the first IKE auth, and the responder sends it in the last IKE auth message that it can, so that you gain, I guess, the most protection possible. And that's also the place where normally the traffic selector payloads go, so it's kind of the natural place for this notify to appear. So unless anyone else has any other suggestions, we'll go with this because I don't have a counter proposal. So next slide.
This is actually very good. I think we have a couple of other, notifies that are similar, like the use transport mode or so on.
If you just do the next slide, I will get there. You'll have to wait 2 more slides. So this is about PFS actually. So since the first child essay comes with the protection of the Diffie-Hellman of the parent essay, the IKE essay, there's no associated KE with the first child essay. So if you rekey that first child essay, what do you do? So proposal 1 is just to remember or pull back the group from the IKE essay and use that one, because that's the one that the original child essay used. So you should use the same group for rekeying. Or you say like, well, this one came in with the parent essay. It didn't really have its own PFS. So if you want to use PFS, we first do a regular rekey where it can change and it can be some other value. And then we, after that, we can do an optimized rekey if we rekey again. My suggestion is to use the first proposal because it seems simpler. Valerie has a comment here.
Valery Smyslov, LSPAS. Can't we use both? So until you make a full rekey, as far as I understand, optimized rekey is optional. So until we make a full rekey, just reuse a key exchange method from the IKE essay. But once we, probably not the very first rekey.
So are you saying proposal 2 or?
No, using both. So as far, do I get it right that optimized rekey is optional? So you can mix it with the regular rekeys. So-
yeah, actually, on a later slide, I'm proposing that we don't do that. But
But if it is optional, then until we make a full rekey, the first full rekey after IKSA created, we use proposal 1. And once we made the full rekey, the all subsequent optimized rekey use the last group from the full rekey.
so that's of course an interesting thing, because if you then rekey with a different group, then I'm wondering if you technically are keeping to the spec where you say the rekey is the same, and that's when we're doing. There's some parameters. There's some parameters
from the last rekey, from the last full rekey.
I understand, but there are some parameters that the IETF2 core spec says during a rekey you should not be changing them, and so cryptographic parameters really is one of them. So if you then start changing the KE group,
But your proposal 2 may change the group.
yeah, I'm also a fan of proposal 1.
Okay, just my opinion.
So next slide.
Oh, there's a Tobias also in the.
Oh,
queue.
sorry, I don't see him in the. Oh. Tobias, go ahead. If you're speaking, Tobias, we cannot hear you.
He hasn't opened his mic. He hasn't opened his mic.
Tobias, the Meet Echo you haven't unmuted on Meet Echo.
I suggest we go on.
Okay, so we'll go on. If you can maybe send it in chat message or figures out later, we'll pick it up. Okay, next slide. So then there's the notifications that are related to the child SA, and they have this property that they are negotiated. So you can send a use transport notify, and the other end can either accept it or reject it. So the initiator has no control over whether this option will be used or not. It depends solely on the responder. So if we're saying at rekey that things cannot change, then we sort of cannot really use these mechanisms, because these mechanisms, the responder can do whatever they want and the initiator has to follow. So the question is, are we going to basically say, don't send these notifies, and then it doesn't mean not to use them. It means use the same as we did on the initial keying parameters. Or do we say, like, you must send the notifies anyway, but if we detect that there's a change, then we just throw an error. And so this applies to all the sort of the notifies that relate to child SA properties.
Okay, Tobias says that I think proposal 2 is better because the IKE and the child SAK payloads are not necessarily the same, in particular when using multiple KE.
Oh, so he's talking about the previous slide, right? About the okay. Yeah, that's a fair point. So on this one, do people have thoughts? I'm sort of leaning towards proposal 2, where we just send the notifies and error if it's wrong, because at least it keeps sort of the syntax the same. Of the, like, otherwise these notifies get different meanings. Like by not sending them, they're sort of implicitly included anyway, which might be harder to codify properly. And Valerie has a question there. But please do not say IP comp. That's the next slide.
Okay. I just think that it's better to omit these notifiers or just ignore them.
So you say proposal 1 is your preference?
Proposal 1, but not error, just ignore if they're present.
Oh, that's interesting. But that might mean that you accidentally get one end doing tunnel mode and the other end thinking it should do transport mode.
Well, you just ignore them and use previous state. If SA is created in tunnel mode, it will be rekeyed in tunnel mode. and just don't pay attention for these payloads. If P accidentally set it, but don't send it.
Okay, that's yeah, that might make sense.
Yeah, the document. So one of the options also is to actually define a new notified saying that, meaning that use the same settings as before. Because one of the idea what there I assume was that we actually say bytes, we don't actually send all the traffic selectors and so on here, and you know, 3 key would be use exactly the same parameters. So we could just here notify saying that transport mode, TFC padding, all of those are same than previously. So it would be third option here to say that we are not sending all the same notifies and have an error. We are not omitting the notifies. We are saying notify that, oh, copy the notifies from the previous essay.
Okay, so I guess that's sort of you and Valerie saying the same thing, right?
Yeah.
Okay.
And actually coming back to the previous one, where to actually include the notify, I was actually talking about, we already have in RFC telling where to actually put the essay use transport mode notify, which says that it's in the same out payload that has an essay payload. That's why I was thinking about it would be, you know, useful to have a similar kind of text for here where you actually include the previous, you know,
So you want me to say, please include the use transport notify wherever you're not going to include.
No. I'm talking the first notify where you actually tell that, you know, the SPI. So we would put in the same you know, out payload that has you know, where the essay payload would be, because it's actually tied to that. You said it, put it in the first and put it in the last.
Right.
I was saying use the same text that an RFC 7296 already says for these notifies. It says that these notifies needs to be in the same out payload where the essay payload is. Okay, so you use the same rules for that notify and all of these notifies that are related to, you know, cryptographic algorithms, and so they are going to be, you know.
Okay, sure.
In case we just, you know, modify sometimes the out payloads and there will be even more or something like that. We still want to be together with the same child essay documentation.
Okay. Okay, so the next slide.
Yes.
So then the IP comp one is a little different because it actually is a payload that has the CPI, so the spy of the IP comp state. So you actually have to send it because that's where you normally send the new value. So then proposal 1 is just send it and include the CPI, just like you would normally do for a regular wiki. And then if it changes, because the IP comp notify also includes which compression algorithm to use. So if they try to switch compression algorithm, either throw an error or ignore the compression algorithm and just only use the CPI payload from it. And the other one is to somehow instead of sending IP comp, to send a second optimized rekey with the protocol of IP comp and the spy length of 2, and then send the CPI there. And Scott wants to give us feedback.
Proposal 3 would be just not support IP comp in this mode, because I don't think it's ever used by anybody.
While I feel you and I would like to do the same thing, I'm not sure if my draft here is the appropriate place of deprecating IP comp. But yeah, maybe some text saying don't use this could be added, but no, that should be in the usage guidance of the other RFCs we do. And Yoav.
I mean, I'm not really an implementer anymore, but last time I looked at checkpoints implementation, we had made IP comp disappear and we still have single des. That's how backward compatible we are. We had single des, but not IP comp anymore.
Unfortunately, IoT people seem to think that compression is smaller, it's better. So it's seeing some sort of increased popularity. Okay, so far I've heard only alternative proposals and no thoughts on these two proposals. So I'll send a message to the list and just see what other people say about this. So next slide. And then there's the error handling. So if for some reason we see an error handling, either based on how we interpret the notifies or based on like receiving a wrong KE payload for the group that we're expecting, what kind of error message should we be sending back? Should we try to reuse one of the existing ones, or should we introduce a new one that somehow says invalid rekey change? And I have no strong feelings here, but.
So this argument. So one of the things that you have to understand that the invalid, some of those like invalid syntax will actually tear down the whole IETF, and the question is, do we actually want to do that in the case, or what we actually want to happen when you actually?
Right. You have a good knack of going to my next slide without pressing the spacebar. But the next slide is talking about fallback and error handling.
No, there is no next slide.
There is no next slide? No, there's a next slide about error handling. Maybe there's, okay, anyway. So one of the slides I did have was what to do when you have a failure in the optimized rekey. Do you just like ignore the exchange and leave the existing SA in place until it expires or until it gets another rekey, or do you actively tear it down? And my proposal was to just leave it in place. So
Valerie, you have some comments?
I think that this is a clear protocol error, and it should be invalid syntax, because it's just the same situation. For example, when you do a regular IETF establishment, and for example, you negotiated to use group A, and for some reason PS send you group B in key exchange payload, because it just behaved improperly. I think it's invalid syntax.
But for instance, if you do let's say you're bringing up a second child and that has wrong things in it that you can't parse or agree on, then you only kill that exchange, right? You don't kill the existing IETF and the existing child.
I think in this situation you can kill the whole SA, because it's just you can see that the PIA doesn't support this protocol.
So in my experience, sometimes which end initiates will sort of work, right? So like if you keep initiating, it might work, but if the other end initiates to you or rekeys to you, then it fails. So there are some tweaks where you can maybe keep the SA up, even though the other end would initiate to you with something bad.
I don't know, but I think that since it's violation of the protocol, the invalid syntax is the most natural way to indicate. And of course, it will lead to deletion of IETF and all child SAs. But that's because the peer just behave improperly. You cannot do anything about this.
Okay, so we'll discuss a little bit more on the list on what to do. I do want to say, just a generic remark, this draft started out as being something very simple, very trivial, we thought. And only when we actually started coding did we realize all these things that were like all these caveats. So again, it's a good thing to have two independent implementations do something before you actually ship an RFC.
All right, so that was the first presentation. Okay, so the next one is Valerie going, or does anybody have any comments on that previous thing? Anything else? No. All right, so let's go to the alternate approach to mixing preset keys in IETF version 2.
Hello. Hello again. It's alternative approach for mixing preshared key in IETF for post-quantum security. The next, please. So this is a brief diagram that shows how RFC 8794 works. So we have two exchanges, IETF init and IETF, and PPK is used in IETF if both P agree to use it. So the next, please. And the problem is that initial IETF is not protected with post-quantum preshared key. It was a working group decision, and because it was intended to be, well, the child essays are protected, and it was more important, and the IETF itself doesn't contain too many interesting data, as the working group decided. And that's why, in case it it needs protection, it can be immediately rekeyed. But in some cases, so I will show for a particular case of GIQ2, this doesn't work. Because in GIQ2, group controller key server should provide a group member with sensitive information in the that very exchange that create IKSA, initial IKSA. So I show in this diagram that KD payload in red is unprotected against quantum computer in this case. So the next, please. And the current approach, as it is advised in the current GIQ2 draft, is very complicated. So how can we use PPK with GIQ2? Just immediately rekey, but rekey can be done only by initiator. So group control key indicates a new notify, please rekey. GM initiate rekey, deletes old IKSA and initiate GSA registration exchange. So total we have 5 exchanges instead of 2. And 2 difficult key computations and so on. Not very good, just. Next, please. So an alternative approach that is proposed in this draft is to use IK intermediate exchange to make it possible to use PPK in the very first IKSA, so they make it secured. So in this case, IK initiator, IKSA initiator gives PPK IDs which it thinks are possible to use in the IK intermediate, and responder selects one of them, and at the time GSA out, in this case GSA out because it's for GIQ2 starts, the peer can have keys that are already protected against quantum computer by mixing the PPK. So, Tero?
Yeah, I have actually 2 comments. If I remember correctly, the GIQ version 2, actually the KD is usually using the wrapped keys. And wrapped keys, if I remember correctly, is using the keys that are actually including the encryption keys there is actually using PPK. But so it actually said GIQ version 2 as a KD, I don't think actually is a valid example of that. But I agree that this is something that probably people want to do. But the one problem I found out in this is that with this, when after the first IK intermediate, we change the keys. And because there's no confirmation that the PPK is actually going to be the same, those keys are actually depending on the PPK. And now if some misconfiguration causes, the 2 different nodes to have a different PPK values, the GSA out or the IK out is going to be just garbage, which actually causes, bad behavior I mean, you get a timeout, you don't get an error.
Yes, thank you for this concern. And
I actually think it's actually very easy to fix, but we need to think about, we just add in the, in the responder, because initiator can't do anything because initiator has multiple identities, so he can't do that. But responder picks one identity, picks one PPK, so he can actually send some kind of out payload which is derived from the PPK.
Actually, that is what my next slide about. Not next, but next. But first I want to thank Tero because he pointed me out this problem.
Okay, one minor note, easy to fix. As it is written, you assume the group controller supports this protocol if it supports both 8784 and intermediate exchanges. That may not be the case. It may need to signal that it supports this particular protocol in particular.
So it is negotiable So, it's not completely negotiable, but, you think that if GCKS responds with PPK-ID with no PPK-ID, it means that it supports this protocol and initiator can start ITEC intermediate.
If the controller doesn't support this protocol, it will get
If controller doesn't support,
it will get this ITEC intermediate where it cannot understand.
If controller doesn't support this protocol, it can be used and you will revert to the 5 exchange use of PPK.
Yes, if controller supports 8784, that doesn't mean it supports this particular protocol.
Yes, but it is negotiable if responder supports this protocol, it returns use PPK and empty use PPK. So it doesn't. It indicates that it can use PPK, but it doesn't select a particular PPK. So you can read in the draft. It is more.
I don't. It doesn't matter. I don't care what the draft says. If you have a group controller who does not understand this protocol, and it gets a ITEC intermediate that it doesn't understand, it's not going to do the right thing.
Then that is that. They will either use RFC 8784 or don't use PPK at all if it doesn't support this protocol.
I think that the GCKS should actually have another notify say that it supports this particular protocol as opposed to these 2 other protocols which are different.
So actually, one of the questions I have is actually, I think that, if the responder responds with both the use PPK and the intermediate, that we could actually say that means that the actual supports is, so it's not allowed to respond with those both supported if it doesn't support this one, because this is the only use for this combination. That it depends what we actually put in this draft.
Pavel, no, because you could use the intermediate exchange for something completely different, right? And have the traditional old style use PPK. So then you would have the same 2 notifies.
Okay. So next. And so if responder doesn't support, then it doesn't respond to PPK identity. It's the answer to your question. And then the initiator may fall back to RFC. And currently in the draft, there is some ambiguity because the same situation happens if responder supports this extension but doesn't have any PPK. And with PPK IDs that were supplied by initiator. So in this case, we may also fall back to RFC, but this makes no sense because responder just don't have PPKs. It has different PPKs. So it is possible to modify the draft so that these 2 cases are clearly distinguished. And in case the responder doesn't support this alternative approach, they may fall back to RFC. And in case it supports but just isn't configured with these PPKs, no PPK can be used in this case. So the next, please. And it's the Paul comment. So Paul asked me to include it into the presentations. So do we need to support using both RFC and this approach so that we use PPK twice, probably different PPKs? So it is not supported in the draft currently, and I see no sense to support it, but I see no benefits from this complication.
Pavel, so I just meant that you could accidentally do this and we don't want this. I didn't want to support it.
We can forbid it. So in the draft. So if you use alternative approach, don't use RFC. Just so the next. And how session key are calculated in this case? So according to the RFC, we have SKD, SKPI, and SKPR that are modified with using PPK. And with this proposal, we just calculate a new key seed, and all the keys are calculated as usual. And new key seed is dependent on the PPK. So the next, please. And it makes this, the way key are calculated, have some problem, and Tara pointed out to it, thanks to him. So if PPKs with the same PPK ID are different, the values are different, then we will end up with the different session keys. And because this key are used to encrypt and authenticate ICOS messages, they just won't be encrypted. The responder will receive garbage and drop the ICOS message, and it won't be detectable. So it's easy, it must be fixed, it's my oversight, and I just forgot about this problem because I should have remembered it, but because it was very obvious when PPK was first, when RFC was 8794 was developed, and we remember at the time, but then forgot. And it will be fixed. It must be fixed in the next version. So the most simple way to fix it is to end some payload, some notify payload that will something like some way of key confirmation. So, for example, the PRF of PPK and concatenation of nonce and SPI to be added into IC intermediate. The problem, the question is who to either it should be added to response or to request. I think that it is more appropriate to initiate it, despite that there are several PPKs. Because in this case, if the key are mismatched, responder can properly respond with authentication failed, and it will allow gracefully end the negotiated the establishment.
This document. So, yeah, then would need to send in the editor would need to send multiple of those, because if each a PPK ID has a separate one, that's there's also thing that we already use in IC version 2. There is this way that we actually do this kind of authentication, second authentication payload in case an EAP, and especially when we are not using key generating method, we actually use the SKPI and SKPR to calculate, this kind of authentication payload with that. And I was thinking about we probably could copy that similar kind of, generation, generating this, thing that we are actually hashing here or of confirming here would be useful, because then we'd be actually reusing the what is already defined there.
But it's too late to use it.
But we already have a SKPI here. But that's actually one of the things. We only have an SKPI with the new, PPK only after only the initiator when we actually know it, we have calculated. Yeah. So and I don't know if this PRF PPK is actually, are we leaking information too much or something like that? I don't know. But yeah, so this is something that I think we need to do, and we need to discuss which payload type we are actually putting this. Are we actually reusing out payload? And if we are sending multiple of these, because we have multiple PPK IDs, then we need to, somehow tie them together. Yeah. And that's actually one of the questions. Yes. Yeah. But I think these are open issues we discuss on the list.
Yes. So it's not difficult to fix, but some work need to be done. So the next, please.
Go ahead.
On the previous, this might be a half-baked idea, so I don't really know. But you could actually just instead of making a payload, you could use a computed ID, just almost the same thing, but just make that the ID instead of the payload. That might actually,
I don't know. Well, actually, a computed ID, I think it's possible, but it will be static.
It will be what?
you will compute ID based on the PPK value. It will always be the same, not? Or am I missing something?
No.
No?
But if it's on the same on both sides, you could actually obfuscate
I
the ID
understand,
that way.
but
Have a different ID for the same.
I
PPK.
was trying to make this key confirmation different for each session. So if we make it dependent on the session values like nonsense and SPIs, it will, even if attacker sees this key confirmation payload, it will always be different. It will depend on random data. So it will have very little information about PPK itself. That's mine, but probably Scott will, or some cryptographers make some better
I
comments.
have one comment on that. I definitely want them to be different every single time, because one of the ideas we have for PPK IDs is also to allow them to be somehow, you could use a pseudonym or replace them every single time you do, so that they are not same every time, so you can actually make sure that they can't be used to track you.
So
yeah, that's why you want to make sure that they are, also this one needs to be same.
that's actually what I was suggesting, is make the ID be instead of making this a data, make it the ID, and then it can change every time.
But the ID is actually, we need to have some kind of ID that we can use to look up the database to find the actual key. So if you have a 10,000 PPK IDs which you can use, each tied to one PPK, and then we need to tell that, okay, we are using one of these 5 PPK IDs, and you pick one of those. And
that is a consequence, yeah.
So the next. So it's just a comparison of these approaches. For DIQ2, it makes 3 exchanges instead of 5, and 1 DH computation instead of 2. 1 computation of oath in case PPK is optional instead of 2. And initiator can propose several PPK IDs. And if used in IQ2, not in GIQ2, so it will be 3 exchanges instead of 2. But if IQ intermediate is used for some other purposes, I don't know, for IQ also announced for some other purposes, that PPK can be piggybacked, so it's will not waste any exchange. And it's only 1 computation files payload instead of 2 if PPK is optional. And again, several PPK IDs. So the next, please. So I think that this approach can coexist with RFC, and it is not a replacement. So for GIQ2, it can be a primary way, and for IQ2, it can be used in situations when IKSA should be secured from the very beginning, if it is needed. So the next, please. There are at least 2 implementations of the current version of the draft, and our implementation and Libris One, and we successfully interoperated during hackathon. So next, please. So is there any interest in this approach, and would working group think about adoption of this document?
so this document is so talking about such here. So I think we need to. I have a feeling that we have enough, interest in the group. There have been several people talking about this, so I think I should be starting a working group adoption call. But if anybody is, objecting to that or has opinions on that, please comment now or during the working group adoption call if when we organize to do that. I don't see anybody rushing to the mic.
Thank you.
So I think I will start the working group adoption call for this. Actually, can you? The question is, do you want to do this first version of this fix for?
I want to do the first version of this fix.
So when you have done the new version of the draft, I will.
Well, probably in the middle of April.
Yeah. Okay. But after you have done that, I will start the working group adoption call. Okay. All right. Then to your next presentation,
Yes.
I think.
So this is a very raw attempt to present extended format for IETF payloads that will make it more easy to use in some specific environments when the current format has some limitations. So the next, please. So what are the problems with the existing format? So first, we have only 2 bytes for payload length. And for some post-quantum algorithms, it is not enough. Actually, there's no problems with the message size itself, which has 4 bytes, but the individual payload cannot exceed 64 kilobytes. And the other problem is that many payloads contain substantial redundancy. There are a lot of reserved fields that are always 0, and there are lone identifiers that only few of them are really used. And so on. Payload length is always 2 bytes, but most payloads, 90% of payloads occupies less than 265 bytes. So the next, please. So there are some proposals for changing the current payload format. It is IETF proposal that just makes payload length 4 bytes. And it is a proposal by the number of authors, CJ, Tobias, and myself, to how to make key exchange payload longer than 64 kilobytes to be used in IETF2. And this second proposal even have implementations. And also there is some draft that currently expired about the compact payloads of IETF payloads, compact format of IETF payloads. The next, please. So the overview of the extended payload format. So we have the draft defines 3 formats for generic payload header. For small payloads, less than 64 bytes, for medium size, and for very large payloads. All reserved fields are removed. And some payloads, some special payloads, makes a very special format. It's for SA payloads and some status notifiers that make them extremely small. So next, please. So extended generic payload header has the following 3 versions depending on the high bit of payload length. So it is either occupies 2 bytes, 3 bytes, or 5 bytes. The next, please. Some payload headers are revised to remove reserved fields and make them smaller. So, for example, selected payloads number of TS is removed because it's just unnecessary. It can be calculated from payload size, and so on. Selector length is removed because it is also can be calculated from the traffic selector size. So it's just minor modification to make payload smaller to get rid of redundancy. Next, please. And for some payloads, they are special. They are very special. So the most special is SA payload. So I will explain it in the later slides. So there are 2 special payloads, SA payload and notify payloads. Why? SA payload contains proposals that can grow to pretty large size if you propose a large number of algorithms with different combinations and so on, and more and more algorithms appear in IETF2 registry, for example, some post-quantum algorithms, so it makes sense to make it smaller. And what about notify? There are a lot of notifiers that are used just to indicate support of some feature, and it is just some features supported, some features supported. These notifiers can be they contain more data, as they are always concerned with the IETF protocol itself. So it can be made very small. So the next, please. So SA payload. No reserved fields. no generic header in proposal substructure, and transform are encoded in variable as a variable length structures. Next. So how transforms are encoded? There are 5 different ways. So we have 1 byte encoding for most popular transform types and for most popular transform IDs for most used, and 2 bytes for some transforms types that are rarely used or future, 3 bytes for transform IDs that don't fit into previous encoding, and from 5 bytes and up to 512, and for those that have either, I don't know, transform IDs from reserved range, so that they don't fit into previews, or some transform types that are from private reserved range. So this can contain any encoder. Next, please. It's just a summary, a table from the draft that summarizes which transform types are encoded, in which transform IDs are encoded in which format. So you can see that most encryption and PRF transform types are encoded, can be encoded in 1 byte if they use transform IDs from a most common part of the registry. So the next, please, is just an example. I take 1 proposal with 3 transforms. With current encoding takes 40 bytes. So it says GSM, PRF, HMAX SHA-2, and just for example, multi group, 1496. And with compact, it takes more than 4 times smaller. It takes only 9 bytes. So next, please. And what about notify payload? Again, it has a very special format. We just eliminate everything and keep only next header and the first 256 status notifications. So in this case, it occupies just 2 bytes for these status notifications. Of course, it should have its own payload type to be distinguished from the regular notify payload. The next, please. So how this extended payload format can be negotiated? There are 2 ways that are discussed. First, I use new status notify, and it's a usual way to negotiate some new features in IQ2. And the problem is this: in this case, extended format cannot be used in the very first exchange in IKSA need. And if you only need large payloads, it's a good way, because it's just a standard way to negotiate new features. But if you want to have compact payloads from the very beginning, in the IKSA need, then it is suggested to use a new initial exchange. It is called X IKSA need. So it is absolutely equivalent to IKSA need, but it may contain payloads with extended format from the very beginning. And in this case, the negotiation is try and receive what you receive in the PS supported. It will reply with X IKSA need. If it doesn't support it, then probably you receive invalid syntax or nothing for the after 3 or 4 retransmissions. And then you will decide what to do, either to use regular IKSA need or don't try to establish IKSA with this pair. Next, please. Transport issues. Transport issues for large payloads are out of scope from this document. There are at least 2 possible solutions. First, use ICO TCP, and otherwise it's difficult to transfer large payloads in IQ2. Or the more interesting approach that is discussed in currently expired drive beyond 64K is to use mixed transport mode when IC runs over TCP. to be able to transfer very large payloads, but ESP is still established as usual over direct IP or with UDP encapsulation. So, yeah.
I'll start by channeling Daniel, who says that with all these changes, you might as well call it IKV3. And
No.
and signal it with appropriate.
Well, it's the same. If you have a new version, you will still have try and wait for result negotiation type. But I don't know. It is possible, but we can keep the current version just as extension.
That was Daniel's comment. Mine is a little different, and I think we're solving two separate problems.
Yes.
One
Sure.
is having like these really large payloads that are over 64K that we need some way to encode, which we don't have right now. The other thing is trying to make the whole thing a little more compact, like 9 bytes instead of 40, which is probably kind of IoT friendly rather than the big payload thing. These are two separate problems, and the solutions are not necessarily the same.
It's true, but I just want to bring an attention to these problems. Probably this draft should be separated and considered separately. But actually, there is some similarities with this problem. At least we have some way to negotiate of using it. But possibly it can be a different way to negotiate it. I agree. But this, I repeat this. This is just a raw 0.0 draft, just to bring an attention and to propose some possible solutions to get a feedback from the working group. But I think the problem exists. So.
Following up on the previous comment, the simple encoding to transfer large payloads, relatively straightforward. The rules you have for trying to compact things, those are incredibly complex. Actually, that complexity scares me. I wouldn't want to do that. So I would suggest just solving the first problem about payload size, large payloads, and again, maybe leave the rest to IKV3.
Okay. So the next, please. So there are some topics to discuss. So it is possible, for example, to read of SPI size because it can be deducted from protocol ID. It is possible to read from proposal number in proposal substructure, and do we need a new payload types or use existing types if this approach is supported. It's all topics for discussion. Oh, and the last is interesting topic, certificates that consume a lot of space, and there are some RFCs that proposes compressing, so it is also possible to use. Tero.
So this is Erkki. So one of the comments I have there is actually, are you touching anything that is outside the encryption, or actually are you only touching things that are inside the payload? You are not touching any of the headers or anything outer header.
You mean IKE header or what?
So is everything that's changing are inside the payload. Payload.
Yes.
Okay. Because one of the things I think would be possible also, we could actually define a robust header compression profile of, taking the regular IKE version 2, inner the packet that we are going to be encrypting or not encrypting, depending on like RSA in it, and actually compress it using this robust header. Robust header compression allows you to do this kind of pattern matching. So if you see this kind of notify payload where this notify here and there's 0, 0s and there's but 0, you compress it to this. And then when you are actually processing in the other end, you actually expand it back. And so you actually could still run the normal IKE processing. Then, through this compression before you actually encrypt it and send
This
it.
is, I think this is the way CTLS follows.
Yes, yes, I think that's actually, and that's why I was thinking about it might be actually something that could be work here also.
Yes, I was thinking about it, but my problem is that they should somehow share profiles, and this is the problem. Profiles should be the same with initiate and respond, and should be agreed beforehand to use it. So this is just a standard RQ2 that have a different format, but it is actually the processing of the message.
So actually, there is no state in robust error compression things. Actually, the rules are predefined.
Yes.
So there's no, you don't have to actually. Both of the ends had always have the same rules. There is nothing, no state in their instance.
Okay, probably should look into this.
But yes, I actually agree with other people that I think we should actually split it into, and the solutions are going to be different in when we actually want to have a compact representation and when we want to actually have a big payloads.
Okay, next please. Oh, that's all. So, as I said, it is just to get feedback from the working group. So I'll appreciate if people write to the mailing list and the opinion. The draft is published, so please read. And
all right, so we have had multiple drafts about this compact and expanded, and they usually have been sharing the same thing. The authors are interested in. Almost nobody is in, which seems to be funny because there's multiple authors who are interested in it, but they are not interested in each other's proposals. So I would actually, before we actually go forward with this kind of thing, I guess it's good that people would actually read and comment on it, but I would actually want to see more people actually interested in this before we actually start, really working on this. So if you are interested in it, please read the draft and comment on the mailing list, and let's continue. No, I don't think we are able to. I think it's better to have people to actually read the draft and comment on the mailing list. That actually gives you more.
Whether we want
Okay, you
handle the large keys.
you take that.
Okay, so I'll start a poll in a minute if we'll just find out how to do it, about whether we want to work on a way to do large payloads. Well, keys are obviously an example, but in general, some kind of generic or key-specific way to encode a greater than 64K payload. So, are you doing the poll? Okay.
I can do it. So.
Yeah. Okay. Thanks.
Like this. That's okay.
Yeah, great. Raise hand or do not raise hand.
Options are those too. So if you think that we actually need to support large payloads, more than 64 kilobytes, and work on that, raise hand. And if you think that this is not needed, do not raise your hand. And use the tool, don't wave your hands in your front. All right, I give it 10 more seconds and then we'll go.
Then of course we're going to call upon the one who did not raise their hand to maybe tell us why.
All right, so it seems to be clear that there is, quite a consensus that we should work on the big payload issues. And I think we should actually have a draft on that. We actually have multiple drafts on that already.
So Paul Wout is just an individual. I would kind of like us to wait and see if we really need it before continuing, because I think most people are thinking of post-quantum things. So if in the end we don't need more than 64K for that, then maybe we don't need to do this work. But or are people thinking of other applications of why they would need more than 64K?
Well, you never know. Maybe CRLs are going to come back in vogue and would like to transfer CRLs.
TCP on that.
So then do the work at that point, right?
All right, so I think Valerie, you have some comments or still?
Yes, I just to answer Paul, because, well, despite the NIST has selected a Kyber, there are also other organization, regulators. For example, German BSI recommends using MAC-Elise. That definitely doesn't fit into IQ2. So I think it makes sense to eliminate this limitation of 64K.
All right, so we are already 5 minutes late, even if I miscalculated, my schedule by 10 minutes.
Hello, I'm Mohsen from Cisco Meraki, and today I'll be talking about
Dr. Closer remark.
today I'll be talking about the new version of our draft on anti-replace sequence number subspaces. Next slide, please. Before I start, a quick recap of the problem statement. We are proposing to use multiple sequence number subspaces instead of you creating multiple child SAs for multi-core performance, QoS, and multi-path traffic. Next slide, please. In the last IETF meeting, it was suggested that anti-replay protection can be disabled. Some users require it to be enabled for compliance. Same is the case for perfect forward secrecy. And increasing the number of child essays increases the number of Diffie-Hellman exchanges, which can reduce performance of the IKE daemon. When we negotiate multiple child essays, the number of IKE2 messages increases by twice the number of child essays. In contrast, the IKE2 RFC, in contrast, the IKE2 RFC were touted fewer message exchanges as an advantage over IKE1. It seems we are losing that advantage when we use per core child essays. Another historical fact, IKE1 allowed only a single traffic selector to be negotiated per child essay, and when multiple traffic selectors were used, multiple child essays were created. IKE2 improved upon that by allowing multiple traffic selectors to be negotiated in a single child essay. It seems we are repeating that behavior when we create per core child essays. Finally, there's a direct quote from the per CPU queue draft. Adding too many essays may slow down per packet essay lookup. Next slide, please. So here's what we are proposing. We are proposing to increase the size of the sequence number field in the ESP header to 64 bits and store the subspace ID in the most significant 16 bits. Additionally, if explicit IV is used, the subspace ID would need to be stored there too. After much discussion, we believe 16 bits is good enough for scalability. Next slide, please. Our second proposal is to add an anti-replace subspaces transform to the IKE negotiation. And we welcome any input and suggestions to improve this as well our proposed change to the ESP header. Finally, we would like to thank SSH Communication Security for the IPR disclosure of the patent they hold on a similar concept. Next slide, please. As you can see from the slide, the amount of memory used increases as the number of child essays goes up. If we have a hub, say, connected to 10,000 spokes, we will be creating about 100,000 tunnels if each spoke or each peer has 10 cores each, has 10 cores. The memory usage also increases by 10x. And in this slide, this is just the user space memory on display. Additionally, if we are using we are installing those assays in the hardware. The number of peers we can connect to decreases by 10x. We are trying to optimize for scale, not just performance. Next slide, please. Finally, we welcome any suggestions and comments on improving our draft. And we would like to ask the question, should the working group work on this and adopt? Thank you.
All right, any comment on that? No big rush to the mics. Okay, Benjamin.
Hi, Ben Schwartz. I continue to think this is an interesting topic and something that the working group should deal with. And I think this draft is a reasonable looking starting point. I'm concerned about the IPR disclosure. I guess I need to go read the terms, but overall, I think something in this direction is worth pursuing.
Thank you.
All right, any other comments? I think Daniel is getting ready for his presentation, or Paul has some comments.
So Paul, this is a quick comment to reply to Ben. The disclosure is actually the standard, can use freely if it's in an IETF RFC. So the IPR is actually not a problem.
Dan Harkins. So Scott reminded me that a company I used to work for a long time ago, Network Alchemy, has some IPR in this space. Unfortunately, it got bought by Checkpoint. So I think Checkpoint owns the IPR. So you might want to see whether it's all yours.
All right, so I think that's it for that. Let's go to the next one then. Or Daniel, do you have some comment on this, or are you getting ready for your presentation?
No, actually, I wanted to reiterate that we are supporting this work, and we would like this work to be adopted in that working group.
Thank you.
All right, so I would actually like people to actually read the draft and send comments to the mailing list and have a discussion there.
Yes, thank you.
All right, so let's go to the next one, which is Daniel, probably going there, continuing there. All right.
Okay. So this is a follow-up from the presentation we had the last IETF. So IETF2 links maximum atomic packets and packet to big notification extension. Next slide. So our problem is that when fragmentation is occurring at the egress security gateways, it requires some additional resource, and under heavy traffic, this leads to some service degradation. So we would like to find a way to limit at least reassembly being performed. Next slide. So when reassembly is being observed, we are basically two scenarios. One which is dedicated to IPv4, when in the middle you have fragmentation being performed by a router, an on-path router. So this happens only for IPv4 when the don't fragment bit is unset. And we may also have what we call outer fragmentation. So when you have an inner packet that is quite large, and fragmentation is happening at this ingress security gateway, so it is actually building some chunks so that no in-path fragmentation is happening. Next slide. So what is happening at the when a fragmentation is happening, the egress gateway is reassembling all the fragments, and then the reassembled packet is an IPsec encrypted packet, and then it is being processed by IPsec. And so we have two. What is new in this draft is that if the packet is too big and can't be handled by the IPsec, what we call the tunnel interface, then we cannot actually decrypt. So we have done a reassembly for nothing, basically. So all that to say that there are actually two limits that are important for a packet to transit, is that we need, what we were looking at is avoiding reassembly, so avoiding the egress node to reassemble all the fragments it receives, but we also would like that the total reassembled packet does not exceed a limit as well. And when that limit is being reached, it's called too big, a packet too big. So the limits that we have for an encrypted packet, so has some impact on the inner packet, because it's it could be the idea is that the changes are propagated to the source, so that the inner packet is being changed, the size of the inner packet is being updated, so that fragmentation does not happen, and the resulting IPsec packet is not too big. Next slide. So this is why because we have two kind of limits and two kind of scenario, we are defining two notification payloads. One which we call LTMA, so link maximum atomic packet notification. So it is basically the size of a packet that does not generate fragmentation. And we have a packet too big notification to inform that the packet can't be processed by IPsec. And so with those two notifications, we're able to advertise the ingress node, what is happening on the egress node. And the idea is that this ingress node is, taking the necessary actions so that the source node is updating its MTU. Next slide. So if we want to go through an illustrative example, in here, suppose we have a mid-tunnel fragmentation. So it is happening in the network, and one of the router is just performing fragmentation. So that fragmentation is being detected by the egress node. The egress node proceeds to the reassembly operation, and if you can decrypt the IPsec packet, is just going to send notifications that some fragmentation has been is happening. And so upon receiving that notification, the ingress node is actually updating the tunnel MTU, so that the source is sending some smaller packets. And so that's how we solve this reassembly. We avoid this reassembly operations. Next slide. So where we are. So far we received quite a few comments from Joe Touch, and in my mind, we addressed every comment that could be addressed. This includes taking the terminology of interior tunnels draft. We generalize that to we do not restrict the mechanisms to IPv4. We introduce the packet to be notification and so on. We implemented this, and it's actually solved our issue pretty well. But I think there is a fundamental disagreement between, I would say, Joe Touch and us, is that in his draft, he's considering the router component and fragmentation to be part of the tunneling mechanisms, and the reason he's relying on fragmentation is that he wants the MTU links and the tunnel MTUs to be some sort of independent notion. But in IPsec, I mean, even if you look at 4301, we are actually playing with those MTU size between the tunnel and the inner packet. So it's not something that so that contradiction is not new, and we've been living with that for many years so far. So I don't think that's something that should prevent the work to happen. Next slide. So yeah, I think at that point we have gone under multiple reviews, and we are looking for adoption for that, so that the document can move forward.
All right, so is there anybody here who would actually, I would like to see more than one, outsource, actually proposing to, so is there any interest in other of the developers to implement this, or do you think this problem is existing and so on? And I don't see rush to the mics, so I would propose that you actually continue the discussion of the list, and we will see if we can get more people actually interested in this. And of course, if not, then we have to think about what to do with the draft, and there might be some other options also. I don't know. All right, that's it. And I think we have the one more presentation from Daniel also, and I think we are not going to be having, we have 8 minutes time, so we are not going to go to the inter-domain source address validation using RPKI, because I think Daniel isn't going to be finishing in that fast. Right.
Oh, I can try. So I thought we had plenty of time, so I apologize.
Yeah, channel your inner echo.
Okay, so I mean 0.2 echo. So what we'd like to is introduce some new traffic selectors which are considering DSCP. So the idea is that, so next slide. We would like to have to be able to negotiate some SA and associate those to a specific DSCP value. So the problem is not new again, but in the past they were talking about, as opposed to traffic selector, they were saying, no, we are not introducing such parameters. Instead, we are relying on a classifier. But the problem with that is that, I mean, the initiator and the responder can have different SA and can associate each DSCP to the different SA. And so at the end, it ends up with it makes the management very complex, and also the negotiation of unnecessary security associations. which is for us a problem because we're relying on the hardware, and we cannot extend those number of essays. So this is a this is the problem we're facing. Next slide. So I mean, we are just introducing a list of DSCP values as a traffic selector, and things are working a little bit differently than from the labeled IPsec, but it's mostly the same idea, to introduce a new something new for the traffic selectors. Next slide. Yeah, so this is an example. It's nothing new from it works in to that respect. It works very much like the IPsec labeled. So next slide. Yeah, so we're looking for a call for adoption for this draft, and yeah, so that's basically our request.
So this document, I have a couple of comments because one of the things actually, so I didn't really get you what benefits you have. So you are saying that the main benefit is because your management is easier when you have the same essay pair using the same DSCP values instead of them to be different essays. But you are not really doing negotiation, I guess, it is because you are not doing. Is there a narrowing defined on this DSCA-based list or not?
So yeah, that's what we're doing. So we provide. What I don't know is that we need to. I mean, I didn't want to have only one value, so this is why I introduced a list. And then, of course, the other P can select only sub values associated to that.
Yeah. And you only have them in initiator TS, not in the responder. So they are, one direct. I assume they actually cover both.
Yeah,
both directions of the traffic.
So we it's something that might be discussed, but I mean, the way it is being defined, it's I mean, you could select different ones for the inbound and outbound essay, but it is not really much something that we are willing to play with. I mean, in our case, it's going to be the same.
All right, Valerie.
I have two comments. First, I want just to make another comment to what Tara says, because, the main purpose, in my understanding, so first, IQ2 is a security protocol. So the main purpose we have traffic selector is for the peers to be in concert that exactly this traffic with these parameters, with these IP addresses, port numbers, and so on, got into this assay. So for DSCP, in my understanding, it is not a security label. It is not a security property. Sure, you should use different assay for different traffic priority, because otherwise it doesn't work. But why negotiate it? In my mind, there's no security properties with it. Just create multiple assays and distribute your traffic with different DSCP values with this assay, so that each assay will. There's no need to modify IQ2 for this. Well, and the second comment for this particular slide, I believe that there is some inconsistency with how IQ2 processes traffic selectors because you think that you need DCSP list 1 to be repeated in TSR 2 because they must be the same. The traffic properties for TSI and TSR must be the same. You repeat port number, you repeat protocol, no, not port, port can be different, but protocol, for example, must be the same. TCP, and it is repeated, and as well as TS DCSA list should be repeated.
Okay. So, I mean, I'm fine with the with having the DSCP being repeated in both in both I mean in the outbound and inbound. That's fine. But one of the things is yeah. So, but the first comment about DSCP not being a security parameter. I mean, it's one aspect that characterizes the traffic. So I sort of, I mean, I would consider that as in a similar way as the IP address or the port number or this kind of parameters. It's to characterize the traffic. And so I missed the comment.
No, you don't miss, but I don't think it is, well, IP address, port numbers, all these things provide access control. From my understanding, DSCP doesn't relate it to access control, so it just prioritizes traffic and allows it for the intermediate routers to be processed in different order, more expedited than this. So.
Okay.
So Paul, be very short because we're out of time. So
yeah, I'll be. So I have a similar concern with Valerie is that if you negotiate one SA and it has this this traffic selector set, then I would think that the behavior is that you send prioritized traffic over IPsec and everything not matching this QoS service will be sent unprotected by IPsec. And that's probably not what you meant. But that's what happens when you only install this one SA. So I agree with Valerie that I find it a little bit dangerous to use this because you must install two SAs, one with it and one without it, to make sure that you don't leak traffic.
Oh, yeah, sure.
All right, so that's it. Let's continue that discussion on the mailing list.
Okay, so the RESOV people, that's RPKI and IPsec for source address validation, they wanted to present it SecB dispatch and ran out of time. They wanted to present here and also ran out of time. Anyway, their draft makes changes to AH, it makes changes to IPsec policy, it makes changes to IKv2, and well, it can't go all in one draft, but and it has some implications for routing and internet. And so what we are planning is to have any kind of a virtual interim to discuss this because this will not benefit from a 5-minute or 10-minute slot in either here or in SEC dispatch.
Yeah, and please also make sure that this is advertised to some of the routing people because we really need routing people and IPsec people in the same meeting.
All right, so thank you all for coming and see you in San Francisco, either online or in place. And at the interim, of course.
And now there should be cookies.